Quantum computing offers a fundamentally new approach to solving problems that are beyond the reach of today's classical computers. Using the principles of quantum mechanics, quantum computers will perform certain calculations much more quickly or accurately than traditional computers. Some of these calculations would otherwise take billions of years or simply not be possible at all. Whilst classical computers encode data in classical bits, either ones or zeros, quantum computers encode data in quantum bits, known as qubits. These can be a 1, a 0, or some intermediate state. We use quantum operations to control the states of these qubits to perform calculations. To do this, we draw abstract circuit diagrams that represent the qubits and what operations we are going to perform on them. However, these diagrams do not truly represent what it is like inside of an actual quantum computer. This is where CQC's world-leading compiler Ticket comes in. Ticket allows you to write your quantum program in a variety of input formats and languages, and then it automatically translates them to be able to run on a range of quantum devices and simulators. Not only does it translate the abstract circuit operations to the ones actually supported by the device, but it also automatically rewrites your circuit to make it smaller and make it complete in a shorter time. This is important, especially in near-term devices, because the longer a circuit runs for, the more noise and errors will accumulate. So compiling via Ticket can actually improve the results of your calculation. When we write circuits, we also assume that all qubits can speak to one another, or in other words, be entangled. However, in many of today's quantum computers, qubits can only speak to their nearest neighbors. So if qubit 1 wants to speak to qubit 3, we have to perform swap operations that allows qubit 1 and qubit 2 to change places, moving qubit 1 next to its desired partner. We call this routing, and Ticket can do this automatically too, making sure it uses the minimum number of swaps. All of this means a user can write quantum programs or circuits without worrying about the particular device they want to run on, or indeed run the same circuit on multiple devices. This makes Ticket hardware agnostic, and for each device, Ticket will make sure you get the best results you can. For major hardware providers, Ticket allows their users to attain maximal value from the devices of today. We have shown the advantage of using Ticket as opposed to other leading compilers in a number of ways, including in the simulation of the ground and excited states of molecules such as lithium hydride. In comparison, Ticket achieves a 60% reduction in the total number of gates, the depth, and the overall 2-qubit gate count. Simulating such small molecules on near-term quantum devices could help us expedite drug development, which is currently an expensive and inefficient process. Ticket and other quantum software products that CQC have developed allow today's users of quantum computers to extract value in the most effective way possible. If you want to know more about how we are pioneering in the quantum field, or try out Ticket for yourself, then please visit our website.